Welcome to Nanochem. This channel will be dedicated to give tutorials about the basics of chemistry and enable everyone to build up the knowledge of physical, inorganic and organic units. I will be also talking about notable figures, recent discoveries, great breakthroughs and theories that drive our chemical understanding to the limits. First I will say a few words about myself. I have been studying chemistry at professional level for the past 5 years. I want to teach you the basics of chemistry as well as to spread my fascination and love for the subject and perhaps interest you a little bit as well. There are fantastic discoveries around the world which help us advance in technology, drug design and even food processes due to the great work being done in research labs and universities. I start off by talking about some old news. Year 2011 was actually the International Year of Chemistry, branded by the United Nations, which organized it. They've had events around the world to engage with the public, had many fantastic speakers give short and long lectures on the discoveries they made, and why is chemistry great. I presume there are many factors why chemistry requires this kind of push, mainly to help us engage with the public and improve the image the subject has. Chemistry is often portrayed as a dangerous, evil science, where experiments on animals, crazy scientists take over. It obviously is very far from the truth, but nevertheless it is perceived as that. I will be talking about chemistry as a central science. There could be many discussions what subject is the central science. Is it physics with the fundamental laws, small blocks that build atoms? Is it maths that allows the calculations to take place and prediction of the final product? Or is it chemistry that enables thought process, atoms to exist and reactions to occur? To understand science as a whole, one must understand that one subject cannot exist without the support of another. Biology and plant science first comes to my mind, where chemistry is essential to understand it. We care about our bodies and what we eat and how we function, and this is all because of chemistry. The reason you can hear me right now or watch this short video is because your body enables you to do it, and it's not because it has a will of its own, but because chemistry happens there. Your body, for example, your ears, receive a stimulus in the form of sound wave, which is transferred directly to your brain, which translates the wave to sound by the means of ion transfer. The reason you can potentially click on anything on the screen of a computer is because a brain sends an impulse to your muscle, which allows this. An impulse is nothing else than a simple positively charged ion which travels between nodes in your body and triggers a reaction. Our body is built of many cells which are considered small living organisms. A basic cell anatomy is fairly simple. It contains several microorgans inside, and one of them is exceptionally important. It is the mitochondrion, which is the power supply of the basic cell. It produces ATP, which is the adenosine triphosphate, and this is our basic energy unit, a bit like a watt in our homes. Production of ATP is done by conversion of glucose into energy by aerobic respiration catalyzed by NAD, which is an enzyme. It enables oxidation and reduction mechanisms and electron transfer between molecules in our body. Those are just simple examples where chemistry is involved in biology. There are many more which occur as I'm speaking. One more I would like to talk about is the possibility of our living due to oxygen in the atmosphere. Oxygen in the diatomic form of O2 is allowing us to breathe via our lungs. Air enters lungs, and as oxygen touches the surface of a lung, it is transferred across to an ion-containing molecule, hemoglobin, which forms a metal ligand coordination bond. The oxy group travels around the human body and releases oxygen in appropriate places like your brain or muscles. Physics is a somewhat harder topic to discuss because it actually talks about the things considerably smaller than those electrons and protons we chemists talk about. Therefore it is actually building atoms before we can talk about them. Nevertheless, chemistry is involved in many experiments around the world, for example in detecting microwave radiation from the cosmos via telescopes. Yes, it is based on physics as well, but it was primarily used for chemical analysis and then applied to physical applications. There are many techniques like nuclear magnetic resonance, NMR, or infrared, IR radiation, which analyze surfaces of physical applications. The development of new technologies, for example in batteries or new semiconductor materials, is chemical advance. It is a hard argument to win whether one or the other is the central science, but each one of the subjects is borrowing ideas of another. In geology, where understanding of rocks has given us answers to many questions relating to the beginnings of life and how it progressed over the past 5 million years, we had to use advanced chemical techniques like carbon dating. To detect the contents of extraterrestrial rock, for example, we must use methods like mass spectrometry, which tell us exactly what are the contents of the rock. But perhaps the biggest impact on our lives had medicine and biochemistry, where advances in chemistry allowed advances in those two areas. The quality of life has been improving over the time, and we live far longer than our ancestors did a few hundred years ago. It is not due to luck or better genetic materials that we have, but because chemical advances in disease cures and better drugs have been created. Discoveries of new drugs happen every year in various places on the planet, and they enable us to live longer or even help us through the deathly diseases. A few decades ago, we didn't know anything about HIV and AIDS, and then it came with scary signs that we couldn't cure it, and whoever had it would die at a young age. Chemistry and heavy research in the field enabled production of new drugs which help fight the disease, and perhaps not completely remove it from the ill body, but hinder its development. The life expectancy of HIV patients was once very short, with deaths coming at 30s and 40s. Now, however, the life can nearly double to 60s and 70s, and it is because of those antiviral drugs. Cancer was also at the forefront of research in drug companies, and there have been breakthroughs using cisplatin complexes, which can cure many types of cancer. There are more drugs on the market now, and more developed, where gold is replacing the platinum, and would help cure more cancers. Chemistry is also very important for environmental science, energy industry, forensic and analytical departments. Without chemistry, we would not be able to enjoy the life we have right now. To summarize the video, I hope some of you will appreciate that chemistry is important in every aspect of our lives. In fact, there are many things that we wouldn't be able to have if chemists were not involved in the development of those new materials. For example, for buildings, or new semiconductors for supercomputers, or new drugs for cancer fighting, or even new fuels for energy supplies. Thanks a lot for watching the video today, and I hope you will watch the next ones as well.